hand. I'm looking at the directory memory initialization, QPI, things of that sort. There's where it actually started. So there you can see the reset coming in from my power reset command and the rev level of the BIOS that I'm running. Are you familiar with catastrophic errors yet, Thomas? So you can get what's called a CAT error?
No.
So CAT error is a catastrophic error, and you need to be able to look at the BIOS. Basically, you'll get some sort of, I got samples elsewhere, but can't see one here. You would get some sort of, instead of that reset type of message, you'd get a CAT error type of message, and it will tell you the blade that had the catastrophic error. And then you're going to go off. Let me break out of here, Control-4 to break out, and UV con to P2, because I now see EFI being initialized, and now I've got a console. So before that, it's dead quiet, and you're not sure what's happening with the system. So watching the BIOS is useful. It's space to drop into EFI. Now, when you reflash BIOS, or there is a power-C or HWC of G-C to clear, you lose your boot order information. So I was just going to take a look at my boot manager, and EFI shell is at the top of the list. Okay? This is my system, not yours. So I'm going to hit an escape to get back here. I'm going to go down to the boot maintenance manager. And this can be done from the OS when it's up and running with EFI boot manager. I'm going to add a boot option. By the way, Jeff, Novell turned down my feature request to support grub on UV. Red Hat does, SLES won't. On a Red Hat, the grub package has a grub.efi that works in the EFI file system. And they didn't want to put that into the SLES version. It was a feature request from U.S. Postal Service because they want to use grub like all their other machines. Now, SLES supports grub, just not grub within a EFI or grub within a FAT, within an EFI environment. So what I do is I just grab the grub.efi from a Red Hat distribution and then put it into my FAT. And I also want to change the boot order. Got to hit enter there. A lot of people don't catch that. Down arrow and then plus sign to move it to the top. But I had to hit an enter. And by the way, if I've got all the blades as a single system, this order list is quite long with all the NICs. And then I have to go down off the bottom of the screen. So like I was saying before, sometimes you can see a cold reset, but sometimes it'll say CAT error, and it will give you the blade that had the catastrophic error. And then you can go to the BIOS, and when you connect, you've got all the prior BIOS output that's available there. Sometimes I'll just connect in with a TEE to be able to save it off into a file. And Jeff, I'm still trying to bug Hetty and Dimitri to get a TIB on the procedure for handling a hang. Hetty says he's going to do it for the past year, but he's busy too. And It keeps getting pushed off.
Yeah.
Oak Ridge was asking for that quite a bit too. So I wanted to play a few memory games, then we'll take a break, then come back and talk swap real quickly. Again, in my opinion, the problem isn't the swap I/O, and having swap there can be an advantage because it can throttle back the memory growth, the intensity of the memory growth. If I run these code 4s without the swap, it's very easy to hit the out-of-memory killer because they'll all grow concurrently at the same time. But once I actually throw physical swap there and they start doing physical swap I/O, they'll start spacing out differently. They won't be as tightly coupled as they were without the swap. And the swap I/O will start throttling them back, but in different throttle impacts. Meaning that when I have the swap on, one program might get all the memory before the other one has actually gone all the way, and then the one that got all the memory does its work and finishes, and then the other one comes in and is able to take up memory. It kind of staggers them and spreads them out a little bit more, spreads the intensity out. I know HRLN is doing that for that reason, just to slow down the impact of hitting the out-of-memory killer. But my main complaint is we don't have a floor to the page cache. And when I am in a memory pressure situation, first I'm going to push the slab down, but then I'm going to push the cache down, which includes my shared text. And that's what I was experiencing yesterday when we thought it might have been a perf top hang. It's just the fact, number one, the cache got squeezed down to 0. Number two, my root was busy with a barlog message storm. So number three, I can't get bash off a root if root is 100% busy. IRIX, we did have a floor to the cache that kind of protected it. One thing I missed from IRIX is buff view, and you can actually see the shared text being squeezed out of IRIX when you got into a memory pressure situation, all your DSOs and things like that. So by the way, since we couldn't get into KDB, we couldn't get a clean shutdown, but we also couldn't get a dump. So that's what the perf looks like, perf top bug. Let's see, I rebooted my system to see if it would work better today. And see if I can get PM chart to work. Yesterday, I had a couple of problems yesterday. The cap locks wasn't working in VNC Viewer. And PM chart wasn't connecting to the system either. So let me see if I can get it here. And it's working today. So rebooting my Windows system helped. Again, I'm going to click on this and edit chart, and I'm going to take steel and get rid of it because we're not doing virtualization. Apply, okay. Now I'm going to do my next one, open view. I want swap. And the third one, open view. I'm going to see if I still have my view from yesterday. Memory, this one looks good. Again, I can click on one of these to actually get it out of the picture here. So there's mem-free, for example. So it looks like my baseline right now, I'm about 300 meg in size. Then I'm going to add in a new chart for disk. Oops, not that one. New open view for disk. Let me do it by bytes instead of IOPS. And then lastly, the trouble here is I've only got so much space in my desktop. Let me go to FIlesystem, which is the space. And I wouldn't really go any further because I can't see everything. Networks would be handy here, but that's when I'm going to do add a tab. Let's just call this NumaLink right now. And I'm going to do a file, new chart, and UV, and then we've got NL for NumaLink, traffic, and I'm just going to pick the receive bytes. The send and the receives tend to pretty much match each other, so I'm just going to keep it simple here. So I've got 2 blades, that means 2 hubs, and 4 ports per hub. So that's giving me 8 hubs, or 8 NumaLink ports coming off of this partition. And then apply, and OK, or cancel. Now I'm not seeing anything. What do I need to do? Link stat -UV capital A. And now I've got statistics. One thing I don't like particularly compared to Origin or even Itanium, I was able to get both NumaLink statistics and these invalidation and snoop cache type statistics. With hub stats, you can only get one of these at a time. So I'm basically right now looking at NumaLink summary. LHRH, local home, remote home traffic. That's what's going on the blade. Then we've got the GRU, particularly the GRU memory traffic. The GRU is basically a block transfer engine out there that MPT is using. And then we've got our directory cache, which is our CC Numa. And then lastly, I'd like to be able to have the snoop cache information along with the NumaLink summary. Let me go in here and add another one here, add tab. I wish that I could do a save all tabs and open all tabs so that I didn't have to do them in pieces. And open view. Memory. And I'm just putting that so that I've got all of memory visible in this one chart. So what I was trying to focus on yesterday was virtual memory, how you make it, what it's composed of. There were some swap exercises to increase virtual memory, and then to figure out where it all went to. And in particular, we're looking at procmem info. There was also a piece to try overcommit memory. I wouldn't worry about that time-wise unless you wanted to play with it. Again, it can break more things than it fixes, in my opinion. And then the other thing was creating and pushing to the out-of-memory killer, and then just being able to profile where all my memory is going to. Let me log in here now. So you can log into Floyd too if you want. So I'm running a program now. The blue, just to check, click there, is buffmem. Buffmem is raw I/O. I'm going to bring up top. And notice right here, raw I/O, these buffers are growing. Now my top, first of all, I probably should not come in through the serial console. Top doesn't handle the wider terminal very well. Let me get out of there. What do I got here now? I'm at 4 gig. Let me actually put free back in. Look at it live. So there it's running. NUMA link traffic, so I can see a couple of ports that are busy doing traffic. Megabytes per second is the unit there. I wanted to log in as a normal SSH account so that my terminal works better. So I'm at 2% user, less than percent system time, nothing under nice, but I am at 3% wait IO time. And remember I said when I'm at a wait IO, I look for 3 types of locks. There's one of them, sync page. Another one is called get request, and another one is called block congestion. If I do a ps-el and grep for actually EF and grep for MD5 sum, I'm basically just doing a checksum on the second drive here. I actually had a site that their cron event, they were generating checksums on their file system, and when they got into /dev, they were impacting the system heavy with all the stuff that they're reading in. I'm going to click here, get rid of free, and there we can see we're already at 10 gig in that thing. Okay. Now overnight, I'm going to run a stress test on an extended 3 file system to generate a whole lot of metadata and see if I can get the journal for the metadata for extended 3 to be very large in memory. Let me also check here cat/proc/meminfo. So my slab right now is very small, 500 meg. So I'm trying to stack up memory here. So now I've fired up another set of programs here. Do have wait IO going on. The raw is still going on. Let's bring up top. And what I've added now is a program called Postmark. Now for Thomas's benefit, in my prior class, I don't want to give away names of programs. I just give you codes 1 through 10, and then you got to figure out what they are. And also because CSA accounting is turned on, I can just pull out code 5 as an example. So I did see an increase in wait IO time, but I'm not seeing it here because these are CPU intensive. We are sorting by this field by default, which I call the hog factor, which is basically the percentage of the last interval I was connected. It looks like we had a CP going on in there too for a minute. Still a little surprised here. PS-E, code 5. And they are all showing running, even though they aren't really running. I'm going to do a crash command on this. And PS Let me just pick one of them. I'm going to do a back trace on 13197. Oh, that's not the right one. 13189. And there we can see a code 5. Now, it was actually sleeping. It's in a page fault, trying to make a directory, and then doing a lookup create, and then it's sitting on a mutex lock. Mutex locks are not showing up in WChan. I go back here and bring up top. Again, I'm not seeing a WChan event there, even though they are. Look at their CPU utilization, 0%. They're not using any CPU time. In fact, you can see here just a little bit of CPU time. Oh, and they're all on the same CPU. That's not good. How'd that happen? Coming in at 1319. Let me just double check here. PBS Pro is in there. That's okay. Let's go into, I'm going to go into dev CPU set PBS Pro and just see what it's got. Capture CPUs, topology. So I got 31 CPUs and it's using all of them. And then cat mems, 0 through 3. So PBS has got the whole system, but we're not using it right now. And I don't have, I was looking to see if I have a boot CPU set or something like that, but I don't. I'm just looking to see why they're all ending up on the same CPU right now, but not seeing anything. Now let me go back to here. I want to get rid of the buffmam. The other thing I want to do here, edit my samples. I like to see more data at once. So now I can see the slab growing. It was at a half a gig here. Before I had that hang, I had it at about 20 gig for the slab. And if I look at slab with slab top -S space C, right now most of the slab is actually the raw buffer header chain for the raw I/O that was going on. And the second thing is RAID-X tree node, which is NFS. Then we got down here the inodes, directory entries. I'm just wondering, let me do a df-watch, df-I. Oh, it's running in home. Not exactly where I wanted it right now. Oh, I know what happened. I lost sticky bits on my scratch file system. It wasn't giving the intensity that I wanted here because it was running NFS and still running on the same CPU too. Okay. Let me try it again now. Not running yet. What happened here? I can feel the system slowing down. PS is running pretty slow. Mostly IO8 going on there. Again, I still got some that are doing a NFS. Let me try to fix this here. My PS is still running real slow. Okay, all that stuff is cleaned up now. That was all metadata intensive inodes and directories, so now let me try it again here. But they are still all coming out on the same CPU for some reason. No, that's the code. Where are we? Same CPU 19 here. The load balancer should be kicking in and undoing this. I wonder. cat/proc/command line. Nope, nothing there. I was looking for isolate CPU or something like that, but I'm just wondering if PBS Pro did something that affected this. I wonder if service PBS stuff.
Dave, you do see some that
come in and spread them out. You're going to say something, Jeff?
There are some that are on CPU 3.
Yeah. Let me do CPU map. I was noticing this yesterday too. Three and 19. I'm just checking. They're the same core.
Yeah.
Interesting. So I'm just checking my login session. I am in the global. And my affinity is to all CPUs and all memories. So one of the things I was just doing now at cat/proc/$$ set. And I'm in the global CPU set. And then I also did a cat of /proc/$/ and it shows that I am allowed on all the CPUs and all the MEMS. Now, even if I fire up off of one CPU, the load balancer should be coming in and spreading them across. So I was looking at the proc command line to see if isolate CPUs was in there, and I don't see anything. This is the only thing that might really affect us. By the way, Jeff, both of you, we no longer need to know BAU. As of PTF3, the Broadcast Accelerator Unit is certified, supported, and working. So there is a newer performance suite that will remove that. And the BAU is part of the hub used for TLB coherency for lazy TLB shoot-down acceleration and handling of TLBs. I don't see anything else in here that would be causing the behavior that I'm seeing right now. So I'm firing up a different program now. Bring up top. So this time I've got something else going on. Let me get going here, get the buff mem back in and get the free back in. So it looks like my buff mem, the MD5 sums, were close to 80 gig right now. So this time I'm running code 9, which is actually a shared memory, SHMEM one. So it's got memory resident right now at about 8 gig, and it should be going up to 9 gig virtual. But that memory is counted 3 times here now. The brown cache clean right here. So SHMEM is in the cache. Also, it is counted in mapped. And then I've also added the SHMEM itself into the display, so I can see all 3 at the same time. Look at all that system time that we had. I could have profiled that with perf suite, but that was all memory allocation and clearing pages. That was basically the allocation of the shared memory space that we needed. And what do we got here now? I'm going to cat/proc/meminfo. And I've got SHMEM right here. So I've got about 40 gig of shared memory right now. I'm going to do a kill all, code 903. This is another thing that was bothering me yesterday, Jeff. I'm not sure if they're not killing easily. I'm not sure what's going on here. They're picking up the signal, but they don't seem to kill easily like they normally do. I want to see perf top real quick here. So I broke out of it real quickly, but here we can see free pages and swap cache. Looks like it's zapping a page table entry for initialization. I wonder if I can still catch one here. Oh, it's already gone. Defunct. Defunct is a zombie, just waiting for it to finish here. Let me see if I can catch one of the others here. Same thing. Interesting that they get marked by defunct as soon as I attach them with strace.
Yeah, you're zombieifying them.
Yeah. I wonder if they'll stick around. We'll find out. A new way of creating zombies for me. Now notice when that program finished, this green, the mapped, went away. That's because the processes that were attached to them are no longer there anymore. But they still exist in cache. They still exist in the SHMEM counter. Let me go into dev SHMEM as well. And they don't show up there, but if I do an IPCS-AM, here they are. Any questions right now?
And to remove those, it's IP. What's the command to remove the shared RM?
Now, you can grab this. I have a script here. That will basically go through and say, give me the unattached field. If it's 0, remove it for me.
Okay.
Some sites will run this as a cron event. Gaussian is a common example of a program that what kind of happens is the batch will kill Gaussian and then it doesn't clean up its shared memory segments and they get left around. I think every Gaussian site I've been to will have a couple sitting around. Now, they're not always big, but in this case, it's what I'm trying to do is create a memory leak. So let me do this now, strace memhog. Let me put into a file, -o file, memhog. Let me just go 5 gig right now. Good enough. I'm going to do more on trace file. And that is basically just doing a memory map. If I go into strace-f t file code 403, oops, -o. -f follows children. Let me do a more on that one. So that one is doing a malloc and a break instead of the mmap. It's mapping a couple things in there, but this is the key thing that's the difference as it's growing. PS-L. Notice it's got a T for it now. That's because I put it in the background and it stopped. And if I go back up here, it looks like I've got 10 stopped processes right now. PS-EL. So I've got all these that are sitting here waiting for a signal. They're in a signal handler. So Thomas, I use wchan quite a bit to see if it's running or if it's sleeping, what it's sleeping on. Anyway, let me kill the MD5 sums right now. So kill -L, and there's the pause. That's what puts it into a stop state, and here's how I get it back. Was that the right one? (176). So now they're all marked as defunct. 17612. That's the bash shell. They should get picked up. They should get cleaned up. Well, we'll find out as we go along. Okay, so I'm just trying to pound on memory different ways. And what I was trying to say here is by killing these code 903s, they're not clearing up their shared memory segments. IPCS-AM. And by the way, there is IPCS-C to see when they got created, who created them. We can get PIDs to see the creator PID and the last PID that attached to it, things of that sort. And timestamps, when it was attached, detached, that sort of information. So you can find out how old a unattached shared memory segment is. So again, once I killed the, so once I killed the MD5 sums, I basically got a trim. All my disk activity stopped and all the buff mem got trimmed away on me. And the gray was the free. So I'm going to do a memhog. Let's go 120 gig if I can. Too big. By the way, the malloc would work. mmap does not. There we go. So again, memhog is using mmap, but it doesn't show up in the green mmap. It is showing up in anon pages. Right there. Oh, notice this is interesting too. When we got the trim, we topped off on memory right there, 128 gig. That resulted in a trim, but we also got stuff pushed to swap at the same time. That is due to the swappiness parameter. We'll talk about swappiness on Thursday. So what I'm trying to do right now is push everything out to swap. In fact, let me do this. Got more CPUs, may as well use them. I'm actually going into an IO8 state here. And what's kicking it up? We're starting to drop data here, and I'm now pushing stuff out to swap. So what I'm trying to get to here is an out-of-memory killer situation. And here's what I was talking about now. I'm in a out-of-memory, out-of-physical memory, and my cache now has been pushed down to nothing. I'm actually dropping data, but I'm actually in a out-of-memory killer situation right now. I started off saying I like to take care of memory first because of the stability issues, but it's also the biggest interactive impact you feel too. I can see here my anon pages grew up to this point, then I started swapping. That thing's still trying to grow. Looks like that thing just finished. But there's what an out-of-memory killer starts looking like. And notice it's giving for each CPU. And if I have 2048 CPUs and getting a lot of these messages, let's see what we got going here. So if I bring up top, let me get rid of some of the stuff here. F-O-W-P. There are those mem hogs running. Let me kill them all. Look, by the way, I do have a extended 3 journal activity going on too. And log weight on syslog. Look at how high syslog is in top. This is what that var log message storm that I was talking about is like. Let's see *-dp 1-5 for disks. And my disk drive is quite busy. There is a top disk. That's been broken for the past couple years. I've got a newer version that's fixed. It got fixed this year. And this is root, not swap. My root device is busy. Now, is this going to work? CD into bin. Not there. CD into home list. I don't have it here right now. I have an IO top that kind of works. Tell me what process is actually doing the IO. Let me see if I can still catch it here. Looks like the event is done. Let's see what we got going here. So there you can see all the activity to root. Some of this was the swap. Now we still have swap full, but we still have lots of memory now. Everything got killed right here. So if I do a swap on -s, I see that all my swap is basically used. /proc/mem info. And very little swap is free. But I still have lots of memory available. What do I got there? 82 gig of memory that's still available on my system, but my swap is still full. *big W 1-5, and I see there is no pages swapping in or out. There's no swap IO associated right now. Everything out on swap is just sitting there. It got squeezed out from swap. Get ready for a break here in a minute. So I'm trying to clean up the workload now. Oh, I got to do a kill -18 to 17765. And now that one's gone. So I bring up top. Notice, Jeff, all those zombies got cleaned up now.
That's cool.
Now again, a zombie is basically a process that still has things allocated on the system. I did have one case where it was an Oracle situation. They were disconnecting from the database wrong, and the zombies were sticking around because of the network socket timeout setting. So I don't know specifically what was holding these zombies for a while, but everything is cleaned up at this point. They went away. Nothing stopped, nothing zombie. I've got a quiet system again. But again, my swap is all full. So what I can do is a swap off -A. I would not do this on a production system, but occasionally, if I go find a system that's got some stuff going on out there, you can pull it back into memory. I think we should probably take a break here and come back and just move on to content, back to the slides. Any questions right now?
Nope.
How about you,
Nope.
Thomas? Anything?
No.
Let's take a 15-minute break, come back a few minutes after the hour. Let's come back at 5 minutes after the hour, okay?
Yep.
Sounds good.
we back yet?
I'm back.
Yep.
Okay. So I'd like to go through this module real quickly. The prior module dealt with configuring swap, but all I'm trying to talk about here is the swap IO itself. Again, my main complaint isn't the swap IO, but it's the fact that if you're swapping, that means you're out of memory, which means the page cache has been trimmed down to nothing, and you've lost your shared text. So identify if swapping is your problem. We've experienced some out-of-memory and swap situations. Those are your most severe. Like I said, I might have a 20-minute stall on a large system as it's going through and stuff. Just before break, we were able to see syslog get busy as we started getting all these messages going into varlog messages. Now that's going to tie up varlog messages partition as well as the swap partition with the IO. And then if you're trying to get bash, your root disk to get it from is also busy. So I was using *big W to see if I actually have any swap IO going on. Also briefly brought up top disk and identified it wasn't swap IO, it was root IO, and then we were kind of seeing syslog pop up in top. I want to briefly talk about memory shortage situations, but we're going to come back to this on Thursday when we talk about sysctl settings. The main daemon that manages memory is called kswapd. So kswapd is the one that's doing the trimming and trying to recover memory when we need it, and then also swapping processes when needed. And then I'm going to talk about sysctl parameters that affect swap IO. But again, I'm going to come back to this Thursday on page cache. So first of all, we really don't like swapping, but I've pointed out the out-of-memory killer is worse than swapping. Adding more memory, but adding more swap just means more swapping. But again, some sites are using that to throttle back the memory growth so they don't all hit at the same time. If you have to swap, get it off a root, get it to a separate disk. Again, if you don't have swap IO, I wouldn't worry about it. In fact, one site wanted a real slow swap, you know, a USB drive hanging off there real slow just to be able to throttle back the swapping. So memory shortage can push everything out to swap, and that's what I was doing just before break. I kind of loaded up memory with buffmem from raw IO and was trying to get a big slab. I'm going to have a big slab again tomorrow. I had one this morning, but then I hung the system in perf top. And this is what I was trying to demonstrate just before we went on break. The stuff that I pushed out to swap stays out on swap until it's demanded. Now, we didn't get that far yet, but the stuff that was out on swap was unattached shared memory segments. By the way, that swap off, bringing it back into memory, is still running. So I've gone to sites where swap-in traffic continues for weeks or until a reboot. So I was using a swap off-A to pull that stuff back into memory and give me a clean swap again. I wouldn't do it in a production and heavy load situation, but news servers, mail servers, things like that, I've done it conveniently. But right now, I don't even know how long it's going to take that swap in to run. So swap IO will show up in the IO8 of SAR and top. kswapd, if you see kswapd in top or top sys, that indicates you got memory management problems. And again, with a wchan, get request and sync page, and we were seeing sync page a little while ago. And then be able to get it down to a per partition basis. So *W will tell me whether I have pages swapping in or pages swapping out. I was also using *big S just to see what percentage of swap was used, or going into procmem info. Now, we haven't covered this yet, but *B, there is a major page faults. I don't know if you're taking notes, but major page faults are not only data pages coming from swap, but could also be shared text coming from the file system. So if I throw everything away, if I trim my cache down to nothing and throw away bash or something like that, when I come back in, and I need that shared text, it's got to bring it in from the file system. That will be counted as a major page fault as well. And in top, by the way, that's end faults. Oops. So you could have configured with no swap and still be seeing major page faults. So that was also known in top as end faults. And again, could be executable from slash, for example. There's also in *R whether pages are being freed or not. And then in PM chart, we weren't looking at paging, we were just looking at the swap allocation, not whether there was swap IO. And lastly, going into bar log messages and looking for killer messages, we were seeing those happen. And there is, we didn't talk about this week, but PMIE is part of PCP. That is a alarm mechanism, and you can set up an alarm to say when you're low on swap, you can set off a pager or run a script or take some sort of action. So kswapd is the kernel swap out daemon. It frees memory when a socket gets full. You get one per socket, one per node. The node and the socket are the same thing in a UV. And it's going to run within the CPU set. So it can be noise within that CPU set if it's popping up and managing things. Now when we run out of memory, we're going to trim the slab first. Then we're going to trim the page cache. Now Thursday I want to try to play this game and actually load up everything and have some raw I/O, a large slab, and then push things down. There are a couple of sysctl parameters that affect this. vm.swappiness and vm.vfs_cache_pressure. We're going to come back to those on Thursday. A swappiness, a 0 says protect user and trim the cache. 100 says swap user and protect the cache. The default is 60, by the way, which is swappy to the user. So some of our systems we advise dropping it down to a 0 so that we're going to trim the cache and not swap processes. Remember, just before break, when we got into that memory trim situation, and I saw the buff mem get trimmed, but I also saw stuff go out to swap. And more than likely, that was the swappiness being set at 60 that caused some shared memory segments to go out to the swap device. Now, one thing I don't have is a tool to tell me what's out on swap. So I have to guess on that. There's nothing to say what are the pages out on swap and who owns them. The other one, VFS cache pressure, is between slab and page cache. So a 0 protects the slab and trims page cache. And 100, or actually going greater than 100 even, protects the cache and trims the slab. Now we'll come back to those later, and if I were to go off to Linux Insight, www.linuxinsight.com, I could find out more details about that. Now last night, before I finished up with Floyd, I'd set a whole bunch of sysctl parameters to exaggerate the slab so that the slab would get as much memory as possible. But then when I hit the perf top hang, I lost that scenario. Now SLUS 11 now does have a reclaimed wait time visible with get delays, so I can actually attach to a process and see how long it's waiting for something. And after we've trimmed the slab and we've trimmed the page cache, then we'll start swapping out user pages. So I'm going to come back to that later in the week when we get into the page cache section. I did happen to catch, I did a backtrace here in a case swap and see the trims. We were seeing some of this yesterday. So here I see case swap wake up, and it was in the middle of doing I/O in this case. This is what's going to count as IO8. IO_schedule will show up as IO8. And the name may change, you know, as kernels change, but block congestion or congestion wait. And yesterday when we were in KDB in the out-of-memory killer situation, we were also able to see zones being trimmed and slabs being trimmed and inodes being trimmed and things of that sort. So there is a sysctl parameter, page-cluster, that controls the swap in size. There is a lab to play with that. It is a power of 2. You can go up to 32 as the largest, and that means the largest request size to bring something in from swap is 128 KB. There's another one that's been around as a workaround for the out-of-memory killer for quite a while. We were using it in Tempo and ICE with /10 SP2 kernels and stuff, but min-free kbytes prevents a memory shortage deadlock. Typically, we were setting that 128K to avoid a kernel deadlock. There have been improvements to the out-of-memory killer such that this isn't necessarily needed as much anymore. Now, I do not know the exact facts here, but as I understand it, the kernel TCP stack is also in this min-free kbytes area. And I've been given information that sites that have, like Oracle and stuff, that have bursty socket connections and bursts of TCP stacks, that they're increasing this to give more headroom for the kernel in that area. But I don't have any facts to back that up. Recently, Oak Ridge wanted to go to 256. Not sure that that really helps, particularly since they were no swap in the first place. Most of their problem, again, was the out-of-memory killer messages going to the var log messages. And there's a PV on that. A couple that I've never used, there's a per CPU page list fraction. I've never touched it. And for older systems, there is the low mem, high mem. This was the older Pentium type of system that had that fake high mem type of thing. So this was for older, I want to say it's i386, not x86. But I don't know of anybody using that one. So SAR-Big W has pages swapped in and pages swapped out, and Floyd 2 should still be going through that right now. And here I'm seeing swap outs. Now, I myself don't care so much about a swap out in terms of the I/O. My process is not weighting it. It's the page ins that I want to be efficient. I could zero out a large array, only use half of it, and want to get the rest of it out of memory. But it's when I need a page, if it's out on swap, to bring it back in that matters to me. Sites that do job preemption do want a fast page swap out so that they can preempt the memory quicker. Now there's also a SAR-B option. This stuff is coming out of proc VM stats. I mentioned it yesterday. So here are my pages paged in, pages paged out. That's total I/O. That's not pages swapped in or pages swapped out. Any physical I/O is going to show up there as well. Then I've got my faults. This is a TLB miss or a minor page fault. A minor page fault says my processor cannot find on the chip's TLB buffers the virtual to physical mapping. So if I can't find it on chip, I'm going to take an exception to the kernel, and the kernel is going to go into the page table And if the address does not exist in the page table, then it's going to allocate it for the first time, put the address in the page table, and then put that back into the TLB buffer on the processor. So faults are minor page faults, which is basically a virtual to physical mapping lookup. Translation look-aside buffer miss, a TLB miss. Translation look-aside buffer, I'm looking to the side of the virtual to find the physical. Now, some of those minor page faults may result in an allocation. Some might be found in the page cache, and some might be out on swap. Then we have major page faults. That means I had to go to disk for something. Again, it could be a page fault for the executable coming in from slash, or it might be a page fault for the data or stack segment coming in from the swap device. Then I got page freeze. So it looks like in this scenario, we have some trimming going on and pages are being freed on the system. And then we've got page scans. So there's a page scan kswap D and a page scan direct. I still don't really know the difference between them. One is kswap doing it, one is the kernel doing it, but I don't see any reason, I don't know why they track them separately. But in this example, they were scanning 3531 pages, and they were able to steal and recover 3459. That showed 3477 pages freed, but out of the total, only 2% of the pages, when you count in these 117, only 2% of the pages that they scanned were stolen and freed up. Everything else was busy. In this other example, I've got 5,000 pages that were scanned, and almost 3,000 were trimmed or recovered. So we got a 57% of the pages we looked at were recoverable. I myself am not really using those, the steal efficiency, if you want to call it that. So SAR-B, again, total kbytes paged in from disk or paged out to disk. That includes any I/O. Faults per second are my minor page faults or TLB misses. Major coming from disk. Pages freed, on the pages placed on the free list, or scanning by the kswap D daemon or the kernel itself, and the number of pages that were reclaimed or trimmed from the page cache. And VM efficiency is page steal over page scans. So first of all, we don't want to swap. Back off on your process size if you need to. Add more memory. I should add in here CPU set declaration. So declare memory needed to PBS torque so your CPU set has enough memory. So again, the site I had a couple weeks ago, they had memory available on the system, but they'd have 4 jobs that were in an situation within the CPU set, and that was impacting the entire system. If you're going to swap, don't swap to root. There is a lab where you're playing with priorities, get swap away from root. Top does have a sort option, so you can find the largest memory consumer. kswap D will show up in swap or have large CPU time. And you might also see shrink underscore type of routines in WCHAN, for example. SAR-big W or top disk will show up if the swap I/O is high. And again, you could have a trickle swap that can occur for months after a memory shortage. And what I was trying to do was a swap off and a swap on to clean up after a reboot. So the lab, and we've been doing some of this, identify if swapping is your problem. If it really is hung, you might drop into KDB, just type in the summary command and look at meminfo. By the way, one thing I don't like that they've missed, the summary command is proc meminfo, but they don't have shmem visible in the KDB summary output. So I don't know if shared memory as part of the swapping problem. Use *big W to see if you have swap IO, or you can use pmchart or top disk. And again, we're going to come back to describing what to do when we have a memory shortage situation. But we're going to trim the slab first, then the page cache. I want to explain kswapd later in the week. And then there is a lab to play with min-free kbytes and page dash cluster. And then also being able to use *-b to look for page faults. Let me just go see what's happening. So I've only got half my swap down at this point. By the way, Control C. Let's just stop it there. Swap off -S. Oops. Swap on, I mean. -S. And I'm down to half my memory. I've only got one swap, and it's at a priority of -1 right now, which is my root. By the way, if I'm doing a swap off and there's not memory available for everything in swap, it will stall or eventually fail. But you could also add another swap. If you added a swap and then turned off one swap, it will move the data to the other swap. Again, not something I would be trying to be doing in a heavily loaded system. Was there a question?
If you were to do that where you try to move it from one swap to the other, would this trickle-in process take less time? I can't imagine that, but just wondering.
No. And again, it's just if you're managing, maybe the swap device is failing or something, and you're trying to take it offline.
Right.
So I'm playing with the swap a little bit just to follow along, and
sure.
I'm sorting in top based on what's swapping, and I turn swap off, but it still shows stuff in the swap field. So
so we're looking at this field here.
Yeah. So should it not zero that out if you turn off swap?
No. I would have called that field SLOP, S-L-O-P.
Okay.
This is a very good question. All they're doing is subtracting the RES from the virtual. So if I malloc 100 gig and only use 1 gig, it'll show up as 99 gig, even if there's no swap configured.
Okay, so it'll look like it'll pretend it's swap, even though it doesn't actually.
It's kind of a hit list, but again, I would have called it slop, meaning that I was sloppy in my mallocs.
Okay, because basically it's reserved, but it's not used?
Correct. So like code 4 was set up to malloc 2 gig, but only use 1 gig. But if you look at the arithmetic, it's just subtracting this from this. And not all programs use all the memory they malloc. Okay,
so correct me if I'm wrong, but does that mean that the pages are allocated but they're not dirty? So they haven't been actually...
Oh, no, they've not been allocated. A malloc is a reservation, so the virtual has been reserved.
Okay.
But I haven't touched the pages, so they never got initialized and therefore never went to resident.
Okay.
So dirty is for write traffic when I actually do I/O to disk.
Okay.
So we got two phases. A malloc is going to reserve the memory, but there is no physical allocation or physical address placed to it yet.
Okay.
Then once I actually use the memory, it goes from reservation to allocation, and then it becomes resident. Now, if I run into a memory shortage situation, the resident might get pushed down, and some of the resident pages might go out to swap.
Okay.
But I'm saying you're reading too much into that field. All they're doing is subtracting RES from virtual.
Okay. So it's really not swap. It's just like you said,
it's just slop.
Okay.
It's sloppy. It's what's the difference between the virtual and the physical. So I was going to sort by the swap here, type in P. And there are things that have very high reservations, but they're only using, like here, 3 meg of the 256 meg that they reserved. So it can kind of give you a hit list of things. I will see things like web servers or eventmon type of things pop up in this display. But again, there's no way to know what's really out on swap. And this is very misleading.
Okay, yeah, because I see there's like a couple of Java processes on my box
Sure.
that are allocating like 1.3 gigs of memory, but they're only using like, one's using 20 megs, but it's got 1.2 gigs allocated.
Now, because of overcommit being a 0, we don't really care about the reservation being over-reserved. But there's also *R 1-5 that says, this is what I have reserved.
Okay.
And then this is the percentage of memory that I've reserved. Okay, *S 1-5. So again, nothing on swap right now. It's completely swap on -S, no swap at all. But if I bring up top, I'm going to go to the swap field, and it's visible there. So you can see Java, for example, even though we don't have swap, it's reserved a large address space. Now, again, common in a threading situation, all the threads have to be able to address into each other's thread areas, so they will often have a very large virtual reservation as well. MPT, OpenMP will do the same sort of thing. But like you said, there's no swap at all here, yet I'm still seeing fields in the swap. So that's just the difference between the virtual and the physical.
Okay.
Any other questions right now? So if I bring up top here, we can see that it is going to go to 100 gig. That's what is reserved, and it's slowly growing to 15 gig. And swap is the difference between them. And I can see it's not waiting on anything, it's running. There have been no page faults yet. So that was the reason that I still keep code 403 around, because it does not use all the memory. Some might call it a sparse matrix solver. So I'm trying to get it. We can see the memhog is actually slowing down in its writes, but they're reserving almost 2 gig, but only using 200 meg, it looks like right now. And then the delta between them is the swap number.
Okay.
I'm waiting to actually start seeing some swap activity here, and then these 200 meg might actually start getting trimmed. This one's at 55 meg. Now by default, they're sorting by this field here.
Okay.
Let me go to O and sort by memory. Just trying to push it harder. So it looks like I have all my swap filled up now. Let me try sorting. Let's see, these memhogs, we're all going to go to 10 gig, but they're not there yet. My other ones actually looks like they got pushed aside. I think they finished. Oh, I got a kill here too. grep-I for kill on the var log messages. And there we can see things being killed. Most of this high system time was due to the allocation, not the out-of-memory killer, I would expect. But there's got to be some out-of-memory killer time in there when we hit out-of-memory right here.
Hey guys, I have to apologize. I have to drop out for a little while. I didn't realize someone had the time zone wrong, but I've got an urgent call I've got to join. I'll be back in probably in about 20 or 30 minutes.
Okay. So, at this point, I was going to go on to the other module. Did you have any questions, Jeff?
No. What's the next module is?
File system layout. You want to take a 20-minute break and come back?
You know what? Why don't I just do the lab? I'll start on the lab for
Sure.
whatever so the next lab would be whatever the 03 lab is, right?
Right, the swap IO lab.
Okay.
No, that sounds
do that.
fine, and let's just regroup at like 5 after the hour.
Sounds good. Why don't you send Thomas an email saying that you'll do that?
Yep, okay.
All right, I'll drop off the phone and come back.
No problem. So we'll talk to you in a bit.
Right.
Hey, sorry about that. I'm back.
Oh, that's okay then.
We still aiming for 10 after the hour?
Let's see if Jeff can catch up.
Okay.
Let me send email to Jeff. Have you worked with SMEE GUI or the RAID tools yet?
Oh, yeah.
Okay. Again, not knowing you, I'm just trying to figure out where we go, but...
Yeah, SME is no problem.
Unfortunately, in your system, all I had was a TP9400 with 10 gig drives.
Okay. I used to own one of those.
Let's see. So I sent him email.
Okay.
By the way, while we're waiting for him, when I look at this system now, if I cat/proc/meminfo, I can see I still got a lot of shared memory, 48 gig. IPCS-AM shows that a lot of that is unattached shared memory. And by the way, you can only see your own if you're not root.
Okay.
So if I were logged in as guest, I'd only see the guest shared memory segments.
And N-attached is how many processes are still attached to it?
Correct.
Okay.
So when it says 0, nothing's attached to it. Now there are markets where that's designed that way, but usually in the HPC market that's not true.
Okay.
Let's see here. So I've got a script that will go through and find anything that's unattached and then remove it.
Okay.
And we can see the swap now getting cleared up. So that was all unattached shared memory segments that were out on swap.
Okay. So I hope you don't mind, but I've been following along by using the labs at the same time because I find that actually trying stuff makes me understand what's been taught a lot better.
That's fine.
And I've hit, so under your swap IO lab, code 4 seems to be an IA64 there, code.
Recompile it then.
Okay, it doesn't seem to recompile at GCC, and I don't ICC on this box.
So let's see, labs.
I just wonder if you have ICC on yours, or if I should just FTP the code over to one of the.
Let's see. We should have module avail. Intel should be there. Let's just find out module load Intel-11.1, and now I can try ICC. It has to do with the random function that's in it, what it's using to populate the array.
Okay.
What happened? Oh. So now it's working.
Okay.
So no, that's fine. Again, we learn a lot more from doing.
Yeah. And it's so rare I have access to equipment to actually do that. Take advantage of it.
So again, I'm checking email, until 10 o'clock at night. Should you be that driven? And everyone's different, but
okay. Jeff
and I will often be online in the evening and stuff. Jeff said
Okay, yeah, I'm usually on
he'll be
pretty
with
late.
us.
It's unfortunately his last. The only time I could get into this course is unfortunately also the last week of our fiscal quarter. So I've got to be a little bit responsive to my sales guys. So they get a little cranky if you ignore them in the last week of a quarter for some reason.
Yeah, I had to get all my expense reports done in time too.
Oh, I better do that.
Yeah, they wanted them done by Thursday. So I just fired off some code for us here to keep the system busy, but they're real small in memory. And here's where we can see the shared memory segments being released. And again, this was shared memory and this was the cache. So cache is counted both in, or shared memory is counted both in the cache and as a separate field. For a long time, they didn't have shmem mem info. And then people would say, where'd all my memory go, and never check IPCS.
Okay.
So it's kind of nice to actually have shmem in there now. Now, if I drop into KDB, it's not visible in the summary command from KDB, and that's something that I've asked for. For me, I'm just a trainer, so I don't get everything I ask for. I got to pick my battles. Like you'd think memory locked would show up in mlocked, and mapped would show up in mapped. But again, my memhog, when I run that, is doing memory map, but it shows up in anon. And shmem is showing up in mapped. We're just waiting for Jeff to join us too. But
okay.
Let's see. Oh, I think I need a size argument to it or something. Hello, Jeff.
Hey there.
I was just trying the, while you were off, trying the mlock. Now, Thomas, we're going to get into dirty data Thursday.
Okay.
So there I'm running this mlock program that I compiled. Double check to make sure it is. Actually, that doesn't look like it's mlocking. I don't see any locks in there. This is a different program than I thought it was. Wrong program. I'm going to have to dig up the correct one. Same thing. Okay, let me move on. So what I was going to talk about, got about an hour, is file system layout. And I would like to talk about RAID a little bit. And both of you have got some RAID background. So really, the lab portions for these is to figure out how things are put together. If I had a large site and a lot of disk drives, I would have some sort of spreadsheet or something to tell me how the file systems are built. And that's what this is about. Also, let me see. Let me go to this, where was it? my little cheat sheet here. So as I mentioned, I generally try to look at the memory issues first so that, number one, I don't hit out-of-memory killer situations, and also the fact that locality and memory placement is critical on a UV. Now when I'm doing an analysis, I look at CPU first, then memory, then I/O, but then when I'm tuning, I deal with memory first, then I/O, and then CPU. Can't drive up the CPU utilization if you're waiting on I/O. Now down in the lower right corner of this cheat sheet, these are the typical problems I'm looking for in file system layout. Distribution first. If I got a lot of drives out there, I don't want 2 drives taking all of the I/O. And I have to be careful, everybody's in RAID nowadays, and so LUNs. We want to understand how the RAID has the LUNs bound together, and then how those LUNs are put together by a volume manager such as XVM. We're not going to cover LVM here. But distribution is basically trying to get all the spindles involved in your I/O that you can. Segregation, this is trying to split out your file systems. So in a segregation, I always say I don't want to be a moped stuck between semi-trucks. I want to split out my I/O streams and optimize that file system for that type of I/O. For example, I don't want to be doing production I/O into home. Batch jobs CD to the home directory by default, and if you're doing scratch I/O there, that's going to impact not only you, but if it's NFS mounted, everybody that's trying to log in, for example, and has an NFS mounted home directory. So segregation is trying to split out your file systems. Head thrashing is another big one. I don't want to be bouncing around on the spindle trying to get to data. I'll come back later to what all the different things that can cause head thrashing, everything from fragmentation of files to too many partitions on a drive. One of the things I always laugh about, the XVM manual says you can partition or slice a drive 64,000 ways. I can't imagine somebody taking a drive and slicing it 64,000 times and then trying to do something with those slices. Everything you're trying to do is reduce contention. Everything is segregate, isolate, split out, reduce contention. Another one is disk full, and in fact, when disks start getting full, all your I/O is going to start throttling back. You're going to see I/O wait times go up, and when you're getting to a full condition, you're going to start getting head thrashing and fragmentation effects. Another common thing I worry about is whether the striping is wrong or not. We're going to come back to this tomorrow when we talk about direct I/O and striping. Bottom line is you want your stripe unit on the mainframe to match the stripe width of the LUN. So we're going to come back to that. In fact, I should do this. A very good sheet to print out. I/O stage is D, Appendix D in the workbook. So what we're going to do starting tomorrow and into Thursday is look at my I/O and poke. I've got 11 places that I can poke into to see what's going on with my I/O. So on the left, we've got our user space I/O, then we've got our logical, then I've got our physical, and then we've got off to the devices themselves. So these are all the different places I can poke in and see what's going on. So let me go back to the methodology. But being able to match striping, I describe this like impedance matching or transmission gear matching. Fire bucket brigade. As I'm moving data around, I want to be well-formed, friendly I/O. I might have mentioned it earlier, but in memory arrays, powers of 2 are bad because they can hit set dissociativity of the caches. But in I/O, powers of 2 are good. Another thing to think about is how the disk proms is set up. This is the thing I don't like about RAID, is being able to get the setup information in a RAID configuration to make sure that they're all set the same. Back in IRIX days, there was a tool, disk prep that basically went out and made sure all the drives were configured the same, written primarily for the video market. So in the disk PROM, every spindle has their own PROM, has their own cache, and there are settings there like write, enable, how the cache is configured, things of that sort. I started pounding on journaling yesterday, and I'm going to come back to that tomorrow. So journaling, the purpose of a journal is to protect the integrity of my file system tree. If I take a service interruption, I get an unclean unmount of the file system, and then the next time I mount, I'm going to use the journal to repair the file system, and basically I'm repairing the linkage between the directories and files. And in a non-journal file system, a unattached inode was called an orphan, and an orphan would go into lost and found. Well, the journal tells me where it belongs, and the orphan can go back into the file system with its original file name. Also, the journal helps tell me where I was in the file system tree messing around, and therefore I don't have to go through the file system entirely from A to Z to check it. I don't have to do a scan disk type of thing. Now, journal events occur whenever there is metadata changes, files growing, shrinking, created, destroyed, and also things like access times. Also, fragmentation of files is a big thing. We'll talk a little bit later about this. Extended 4, by the way, has now picked up a lot of the XFS features to reduce fragmentation. Two things that Extended 4 picked up was delayed allocation, and this is where we suck the file into the cache and let the cache be like a shock absorber, suck it in, and stall a little bit, pause a little bit for the allocation to give a better idea of how big the file is going to be. Therefore, we can allocate in bigger chunks and reduce fragmentation. The other thing Extended 4 picked up from XFS was extentless. We're going to talk about both of those things tomorrow. And then partitioning. I don't believe in partitioning drives except to protect capacity. So I might have a root disk and I want to get temp and var temp off of it so that they don't fill up root and cause a full root. But at the same time, if I'm partitioning and they're active partitions, that means head movement to the other partitions. And another issue is just multiple processes on the same file system and job contention or I/O contention between the jobs. Any questions about those basic problems? So after I've got my memory figured out, I want to look at my file system layout. And the first part of this is inventory to determine the physical disk and the logical file system layout. Now, in the back of, let me go here. Let's see. So in the workbook, the back of it, I was just looking at the methodology, the cheat sheet, but I then have a blank disk farm, 2 disk farm diagrams. And what I have it for the lab is basically to fill this out. This is for a machine called Kramer. Now, Kramer's Itanium, but the thing I have here is a complex file system with multiple spindles. And then I have a example of an answer. So here I'm marking each of the file systems, how they're built and how they're put together, what devices are in them, the LUNs and stuff like that. So that's the main thing that the lab is doing right now, is just figuring out how Kramer and Floyd 3 are put together. And Floyd 3 doesn't really have RAID on it yet. So Kramer is the main one to look at. So I want to talk about splitting out file systems and segregate the I/O. The disadvantage here is that you chew into capacity. The other thing about splitting out file systems is for example, if I take stuff off a root, there could be a lot of disk space on root that gets wasted. What do I do with the rest of the disk drive? I don't want to put everything across everything. I mentioned the other day one site that would take 4 devices, just as an example. Let's say they took 8 LUNs and partitioned them 4 ways and then built 4 strives across those 4 LUNs. They've now created contention if all 4 file systems are going to be active at the same time. Now to trace my I/O, I'm going to start doing this tomorrow again, but using fuser, VUM, to figure out what processes have files open in a particular file system. The main thing in this module we want to talk about are the disk statistics. I want to talk about Scratch I/O, and then be able to look at the disk statistics with DKViz, top, IOStat. A lot of people use. You can draw a line through this one. I don't maintain part stats anymore. It's just an awk script that prints out proc disk stats. So again, the more disks there are, the better chance things are performing well. My problem is I've only got a second disk. Now Floyd 3 does have a TP9400 on it, but I'm constantly losing spindles on that thing. Try to revive them, but they go away quite a bit. Now when you look at what I did with the TP9400 on Floyd, I'll explain why I did what I did later, but see if you can figure it out. Again, you get what you pay for. When I'm shipping RAID 5, I am losing a little bit of capacity, and the TP-SMEE GUI will tell you how much capacity you're losing as you're doing RAIDs with 2-way stripes. I don't know if either of you have had Mitch Mueller's class, but I kept picking on him because he would always do RAIDs in a 7+1 type of thing, and I would always do powers of 2+1. So again, powers of 2 are good, so 2, 4, 8, 16. But he'd do a 7+1 just for convenience because it would fit into the tray or whatever. But again, powers of 2 are good. I'd rather stripe 2 wide, 4 wide, 8 wide, 16 wide. 3 wide, 7 wide are not very friendly. The other reason we do RAID 5 primarily is for reliability, so if a disk drive fails, we can remove the drive, and using the parity information, we can reconstruct the file. And the other thing you have to worry about when you are laying things out is whether you need bandwidth or latency. So I don't think Thomas has heard my story on this yet, but earlier in a class, if we're all in the same classroom, I'll pose the question, which is faster to get this class to downtown, a Ferrari, a school bus, or a 747? It all depends upon the class and how far downtown is. In other words, I didn't say which is faster, I said which is faster given this payload characteristic. So if there were 2 of us in the same room, a Ferrari might be the appropriate device, as long as we can fit into it, and that's the key thing. Does my payload fit? This goes back to page cache and interleave round robin versus locality. If I can hold my stuff on node, I don't want to spread things across nodes. I want to keep it on node if possible. So again, which would be faster to get us to downtown, a Ferrari, school bus, 747? If there's 2 of us and we fit in the Ferrari, that would be the best choice. If it's a long distance we're going and there's a lot of us, a 747 would be a better choice. Now keep in mind the 747 is traveling 400 or 500 miles an hour versus a Ferrari, but it's not the best choice for the payload situation that I was describing. And then the school bus would be the best choice if there were 7 or 8 of us. So what I'm talking about here is the school bus is your SATA drive that's decent for bandwidth but has large capacity. The Ferrari is your SAS drive. They're spinning faster. They have lower latency. And I would rather have a low latency SAS drive for my root because of the nature of the I/O that goes on root. And then the 747 is my RAID device. It costs more, but is meant for large data movement, such as video streams and stuff like that. You get the general idea of that, Thomas?
Yeah, I thought you were going to call it the 747 tape, though, because you've got the whole ramp-up time and then the high
There
ramp.
are times I can burn DVDs and drive the 100 miles to Chippewa than it is to move them.
Absolutely.
I've done backups to my laptop sitting on a cable modem at home from Chippewa Falls, and I'm in Egan, 100 miles away, and it takes over a day. I could drive there, dump it to DVD, and drive back quicker.
I believe it.
So anyways, the key thing here, though, is when I can keep it local, if I can keep it on node, I want to be latency critical. When I can't, like a video stream, it's not going to be held local, then I need bandwidth. So it goes back to, can I keep my payload local or not? So there are a lot of times, for example, in the video market, we're tuning for bandwidth, but in the database market, you're often looking at latency. Okay? So some RAID devices and how you configure them. You might be configuring it for bandwidth, or you might be configuring it for latency. Again, I want to try to separate my file systems out based upon the I/O characteristics. So there are database markets where the metadata index is on a file system designed for latency, and the video assets are on a file system designed for bandwidth. Did you ever work with Grio in real time, Thomas?
No.
Okay. So in the real-time file system type and guaranteed rate I/O, they're splitting the assets away from the file system. So all your inodes and little files are off on the normal data portion of the XVM file system, and then your video assets are off on the real-time volume. Now that's kind of been dropped in Linux, but the main thing they missed was they were using Casina and loading assets and then running their benchmark. And they saw no difference between real-time and a normal file system. But that's because the disk drive underneath was the same device, but the key thing was they didn't get into a fragmented state. If they'd run their experiment for a year and loaded and unloaded assets and got their file system into a fragmented situation, the real-time was separating the video assets away from the inodes and everything else, reducing fragmentation on the video assets. But they just did a make-fs, loaded their assets, and they didn't have a fragmented file system. So they never saw the difference. But that's another example of splitting out your file systems. Again, know your workload. And part of this is knowing whether you can do a direct I/O, raw I/O, or buffer cached I/O. Your default I/O is through buffer cache. You can open a file and do direct I/O. That's quite common in the video market. And then raw I/O is like that MD5 SOM, or Make Swap, by the way, does raw I/O. I kind of wanted to go back maybe tomorrow with that Make Swap scenario that you had. And you ought to see BuffMem growing for the size of the swap that you were putting together. Do you know how big the swap was you were trying? Was it the 100 gig? Was it the whole drive?
No, it's only, I think, 9 gig.
Shouldn't take that long for a Make Swap to do 9 gig. And,
no, that's what I thought.
That would have been an SDB, fairly new drive, so I doubt there were bad blocks or anything like that going on. But I'd kind of like to come back to that when we get a chance and look at that.
Okay.
Kind of help me, I'll make a note, but kind of help me remind me tomorrow on that Make Swap. So part of knowing your workload is using strace. And that was that big thing. I'm just going to plop to it here. This chart that's in Appendix D in the back of the workbook is understanding your I/O path. So some of the tools, LSPCI. Jeff, do you know what we do with LSPCI these days?
Complain about it a lot. Oh, no, you're looking for the worldwide name. Okay.
No.
Oh, yeah. Well, you can't do that, though, because then you can't find the Ethernet adapters. But, yeah, you do that a lot. Cause
Do you follow me, Thomas? There's a lot of Intel stuff in there, and we try to get rid of that noise.
But then you end up saying, oh, I have no Ethernets.
Yeah, but again, we're in the file system inventory area. So I don't disagree with you. But the Intel stuff gets real noisy, so we kind of like to filter it out. The other command, lscsi, I want to demonstrate. The problem with lscsi is it's going to show alternative paths. So if I've got 4 paths to the same device, the device will show up 4 times. And in my inventory, I'm going to show you a little script I wrote that basically prints out 1 line per ID and then shows all the paths to that particular device or LUN. SAS map I don't really use. I think I heard it was going away again. You know anything about that, Jeff?
No.
One thing I missed, when I was in IRIX, we had a tool called bstore, and it could generate me an HTML table format of my file system layout. And I still wish for that. The main thing that we do need to worry about is going in by ID. By ID is basically the serial number and is going to be guaranteed unique. And by the way, for your information, Thomas, if you use AutoYast on a UV, I have one AutoYast file I use for all 4 devices, so I use SDB instead of by ID. That way I know that it's the exact same AutoYast file for everything. But you need to know in an AutoYast environment, the virtual DVD is SDA. And I could do it by ID, but then I have multiple AutoYast files that deviate from each other and create problems.
The DVD shows up as SDA?
In an AutoYast environment, when you're at that AutoYast level. The order is all going to be based upon kernel modules being loaded and scanned. And by the way, you were talking about your IRUs having multiple parts, each IRU being a separate partition.
Yeah.
You're not going to get predictable device naming schemes if you go to a single partition. So some sites are complaining about that. So you'd think the lower left corner would be your SDA, but in fact your upper right IRU might be SDA. So it becomes messy to figure that out.
Devil.
Comment?
SD naming is the spawn of the devil because
yes.
It moves around. It depends on the discovery order. You particularly see this, as you know, in ICE clusters where the kernel does, the installing kernel is one kind of kernel and the real kernel is another kernel, and you can get really confused.
And some of it can be the order of kernel modules being loaded and then the discovery on the bus. Now, just to point out, though, on Itanium, we did have a pod command that would give us a scanning order, and then it's more predictable. But at this one site, they did not like the fact that if you did a DF, it would show as SDG rather than SDA. So even though they were mounting by ID, when you do the DF, it's by name. You okay with that right now, Thomas?
Yep.
HW info --disk, which I miss having on Red Hat, and I am going to show you what I do with that. Part probe will show me the partitions that are out there. DF-H, and I also use a -I in my inventory to see how much inode and metadata they have. And then, again, Thomas, you mentioned some XVM background, so a -top to give me my topology and a -E. And then verbose to see my slices, XFS info to see how the file system was made. LSI util is what you need to figure out if you've got hardware mirrored devices for root, for example. If you got LVM, there's LVM disk scan, and then DM setup for the device mapper. And if it's an extended 2, extended 3, a dump E2FS to show me how that file system was made. And SGI mode tool. I think it changed its name. Now it's just SGI mode. Did I get that right? Hang on a second. Yeah, it's SG Mode Tool that changed its name. So that's the new name, I got it right. But I do need to fix this, use SMEE nowadays. Workstation Edition is being retired, or is it already? Anybody help?
I think it's retired to the...
Yeah. The trouble is that you go out there and you can find lots of different things that are still old. Jeff, I'm surprised I'm still finding a lot of ProPack 7 SP1 running on UVs and nobody's upgrading their performance suite, and they don't know how to. So that was true at Oak Ridge, for example.
Yeah.
In ProPack 7 SP1, there were quite a bit of improvements in the past year. So during my inventory process, the first thing is the bus ID. That's basically the order of discovery. We'll come back to that. Alice Scuzzy showing that. Device name, and that's the part we were saying is not persistent. And then what is persistent is by ID. That will always be unique. By path, as long as I haven't moved anything around, is going to be unique. But you might have things where you're shuffling drives around or something like that. Then we've got by label. Now, if you label the device, by the way, there is a udevadm command trigger. And that's going to rebuild these entries. So if I label something, it's not going to be in by label or by UUID unless I do a udevadm trigger, and then it will reconstruct those directories. And UUID is from the super block when you make the file system. There's a universally unique ID there. But if I remake the file system, that UUID will be different. You do have the ability of specifying a UUID as well and changing it later. Also want to know the vendor, the model, and my SCSI, SATA, SAS needs to be added in here. What's the size of the drive or partition or LUN? And one of the key things I do when I start off is hwinfo --disk, and then I grep for device files. And that gives me all the different ways of specifying the same device. So let me get to a demo in a little bit here on that. So this is just an example for Kramer, and I was hoping that you'd spend some time. Kramer's root password is SGI, and log in and see how it's built right now. I haven't even checked lately to see what I left it in last time. By the way, in this case, it was daisy-chained SCSIs, and in a daisy-chained scenario, the lower the ID, the higher the priority on the bus. So in this example, Scratch actually has better priority than Home, and Scratch can actually maroon Home. Okay. So I just was showing you in the back of the workbook, there was an example of what Kramer might look like. But I'm going to look at that tomorrow as a group. So again, split out your file systems. We try to spread things out to separate controllers and separate disks. Again, know your I/O trace. There's three ends of the spectrum to me: latency, bandwidth, and metadata. So latency is like online transaction processing, credit card processing. Home directories are latency critical. Bandwidth is typically your HPC market and your video market. And then metadata is things like Varspool News, Varspool MQ, Varspool Mail. You can get other applications that are metadata intensive as well. The satellite surveillance market, as the video file is coming down and the file is growing for it, that can be very metadata intensive as well. For latency, I'm going to want to look at SAS types of drives. For bandwidth, possibly SATA types of drives. For metadata, I would like to avoid a cluster file system like CXFS or Lustre, because every time I work with metadata, I got to go to the metadata server and lock the metadata out. So Varspool News, for example, is not going to be very good on a clustered file system, a distributed file system. The home directory, trying to get them off a root, get some sort of Scratch directory to do your Scratch I/O. My last site, they had a Scratch dir environment variable and a directory for each user created there. but there was nothing in message of the day to say use it. So I was using my NFS home directory, and that was creating interactive performance impact. So I want to get that I/O away from home. Don't run file systems full. Now I'm putting it at 75%. You can pick your own number depending on how big it is. The problem when you start running file system full is fragmentation. Also, I want to know my I/O request sizes. Am I doing large sequential or small random? Big difference. That goes back to my latency versus bandwidth. Also, am I reading more than writing or writing more than reading? A web server is typically going to read more than write. A video server is typically read more than write. But video satellite surveillance coming down from a satellite is going to be more writes than reads. And when we get into the I/O path later, this behavior can change at every step of the way. So that's why I've got this drawing here where I'm able to go in and see what's going on at all these different phases, stages of the I/O. I want to know if I'm NFS or CXFS, Lustre being the Oracle-based file system. Was Oracle going to do anything with that, do we know?
Yes, they're going to abandon it, which they already have, more or less.
Yeah, that's what I thought.
But the nice thing there is it now has come back to having a better home. Wham Cloud, which is another vendor, has picked up most of the Oracle people that Sun picked up that they got from Cluster File System.
Okay.
And there's now a consortium. So this year will work, the details will get better worked out, but it looks like you'll have a real non-vendor-owned Oracle.
Okay.
Sorry.
What about kernel integration? Is there ever going to be anything like that so I don't have to have special kernel spun?
There's probably a better shot for it now that it is a consortium, but I don't think that's driving the consortium. So
now I heard
you'd
from
have to get somebody in the Linux community to say this is good enough code that we're willing to try to get it into the kernel, and then there'll be the usual 2 or 3 year wait for that to get into distribution.
Sure. But I'd heard from Jay at NASA that they were interested in CentOS because of Lustre integration. I don't know anything about that.
Oh, no, that's just because Oracle integration, the Oracle integration layer for Lustre has always been based on Red Hat because Oracle Unbreakable is based on Red Hat. So that's the direction they were going. The direction that NASA is going for CentOS for the servers is because then they don't have to pay an operating system vendor.
But they are still integrating themselves. It's just easier to drop into CentOS.
Yeah.
Okay. Thank you for clarifying that.
Sure.
Past that, then you get into politics. In my data center here in Eagan, there are 3 people on my NFS partition file system, but not the whole building, so I don't get everybody mad at me when I start pounding on something. And then setting up disk quotas. So my last site, my home directory had disk quotas set up and then a scratch directory that was GPFS for large sequential type of I/O. Moving on, though, there's something, this is kind of an old term. In Cray days, we usually actually documented it. The crossover is basically bandwidth times latency of the drive. And what we're talking about here, as I start striping, my latency stays the same because the spindles are still spinning at the same time, but my bandwidth is going up, and therefore the crossover was going up. Nowadays, instead of using the term crossover, they simply say this drive has been configured for the database market and this drive has been configured for the bandwidth market. So basically, in the old days, you'd figure out the crossover of the drives. We actually had a man page in Cray days that would give the crossover of the supported drives, and then you'd pick low crossovers where you needed latency, and you'd pick high crossovers where you needed bandwidth. But the terminology has dropped out of favor. People didn't know what to do with the number because they'd get a raw number and try to make meaning of that number itself. The real meaning was how was that number relative to the other devices. So again, basically crossover was bandwidth times latency. High crossovers were good for /video. Low crossovers were good for online transaction processing. And now the sales sheets will try to say that this one has been optimized for a particular type of I/O characteristic. Again, I want to try to keep minimum partitions per drive. I don't want head movement between them. If I do, one of the problems I have is if I do decide to go to an external log, these drives are very big. I need to do something with the rest of the disk space on that drive that I put the external log on. And I don't want to put all my external logs on the same drive or I've now locked them together. So I talk about dormant file systems that you're not using, like var crash or something like that. Backups, clones, things of that sort, to put on the rest of that drive. And again, key here that we're going to get into tomorrow is know the I/O patterns of your application. So here I was just trying to say video market is bandwidth, XFS is good for large sequential I/O. Extended 3 is actually better for root and for lots of little IOPS. XFS is better at large sequential allocations, and striping is common and that type of thing. Home is kind of in the middle, but in general I call it a latency file system with lots of little IOPS, but not high I/O intensity. The online transaction processing for credit card transactions is going to be latency critical, lots of little IOPS. Now, one thing that was fun at U.S. Postal Service, they're building their database with online transaction processing, but then they're post-processing it, what we call strategic business analysis or data mining. So they need to tune for the online transaction processing at the penalty of striping through the data later. So it's important for them to have the quality of service at the credit card point of sale than it is for them to post-process the data later. And the other end of the spectrum is metadata intensive. Now, I was using a command called postmark that's out on the web. That's my code 5, and it's pure metadata. It's meant to emulate email spam attacks. So varspool news, varspool mq, those sorts of file systems are going to be very metadata intensive. Every email has 3 inodes to it. And I was trying to get to a hot journal, and I'm not sure what was going on today because all the code 5s ended up running on the same CPU. I still don't understand what happened with the CPU scheduler there. I'm going to have to think about that. But going to an external journal to reduce, we were seeing yesterday a lot of XFS log waits and stuff like that, to be able to reduce the process waiting on the journaling activity. I don't want to bottleneck on the journal. So we're going to come back to that tomorrow. Now my plan is to wrap up this module today and then cover RAID briefly tomorrow, but go ahead and take a look at the RAID lab. But tomorrow morning I want to do XVM and then after a break do XFS. So I need to know my I/O characteristics. I want to know if I'm reading more than writing or writing more than reading, and this helps me decide things like read ahead and cache considerations. Secondly, I want to know my transfer size. I need to use strace to figure out am I doing large sequential or small random. By the way, let me come back to it later. A block trace is a command that I'm using, and it is going to be working in SLAS11 SP2. I know that it's working in the kernel of the day, and I've got an RFE to make sure that block trace works. And then is a command called SeqWatcher that can actually plot this stuff. And SeqWatcher came out of Oracle. So with SeqWatcher, you can actually watch the head movement and spot sequential I/O or random I/O, record referencing I/O. In fact, this is why Oracle created ×10 so they don't have to go to disk for this stuff and can do all their random I/O in a memory resident database. Also want to know if I'm doing 3 types of I/O, my default is cached or buffered. Again, in my mind, cached is the read traffic and buffered is the write. So when I'm writing, the kernel is going to buffer or sectorize my data until it's well formed and then send it off to disk. Also referred to as a lazy write. I don't have to worry about everything being on a sector boundary. I write 1,000 bytes, and it worries about it being sectorized. Second type of I/O is direct I/O, or DMA. That's going straight from the fiber channel, for example, or the SAS controller, straight into user space, not going through the page cache. So we're going to do direct I/O tomorrow morning with XVM. We've already talked about raw I/O. And again, watch your make swap for raw I/O. XFS dump, XFS repair, XFS DB, the XFS defragger, all those sorts of things are doing raw I/O. That means we're not using inodes, we're not using directories, we're not using superblock, we're going straight into the raw space. I don't know if I'm doing synchronous or asynchronous I/O. So in the database market, they may stack up asynchronous I/Os with a list I/O. Give it a list of async I/Os to do. Am I doing formatted or unformatted? Am I doing memory mapped? Read, write, write. I have OpenOffice typically running on my laptop, and it periodically checkpoints the file that I've got open. So you can actually see it checkpointing periodically. So I read it in, and then it's going to sit there, write, write, write. Now, read, write, writes can affect RAID because when we do the write, we have to generate parity. Also, there is a time window. If I do a read, a write, and the write has not flushed to disk yet, and then a second write comes along, I've got to be able to cancel the prior write. And Linux is counting write cancels, but I don't know of a tool to get to it yet. So if you actually looked in proc PID, there is a file called IO. And the tool top IO, or IO top, goes to that file to sort out top processes doing IO. But I don't know of anything that's printing out the write cancel field in that particular file right now. Again, I want to know if I'm bandwidth, IOP, or metadata intensive. Also, I need to worry about flushing. So sites that are worried about the reliability of their data, they want to make sure the data is on the media before they get the I/O done. Otherwise, I could flush it from central memory or from main memory. It goes off to a RAID controller. The RAID controller caches it, and my application gets an I/O done. And then maybe the RAID controller has some sort of reliability problem. Maybe it's RAID 0 and not mirrored, but the I/O done is already received by the application, so we don't know what to do with the bad data. Also for power losses, things like that, to be able to make sure the data is flushed to the platter before we actually get the I/O done. And then another area, am I doing parallel I/O or not? So get your I/O off of root, swap away from root, get homes onto their own disks. Jeff, I've always been annoyed that they do a /data1 on their root devices when they ship from the factory. And I see a lot of sites that aren't using that space in any way, shape, or form. And then they have bar temp and temp that are attacking the capacity of the root drive.
But manufacturing has no idea what the customer wants to use it for. And the decision was to mount it so it's a little more obvious that it's there than to simply leave it alone.
Sure. But again, a lot of these sites still have slash wide open with bar temp, bar spool, and temp that could fill up that root. And then they got data one sitting there that's empty. Anyway.
And there's nothing manufacturing can do for that. I mean, you know, you could get...
Agreed.
The SEs could write into the code tool and say, here, do this with the root disk. But if people do real I/O to their root disk, that's a fundamental problem to begin with.
Yes. Yeah, and that's what I'm saying, get I/O off a root. So, again, the manufacturing doesn't know the best scenario, but that needs to be worried first thing when you get it to site. You okay with what I'm saying, Thomas?
Yep.
So again, I get it off a root and then fan the I/O to as many controllers and disks as possible. Spread them out round robin among controllers. Now, one of the problems here again is affinity. The XVM engineers are working on a new path manager to control paths and how I get out in a alternative path situation. But being able to again, in my I.O. situation, being able to pin my I.O. to the node where the controller is so I don't have to go across the interconnect to get to things. If you look in my home directory, I'll show you later on Floyd 1, there's a pin I.O. example. In fact, I should have it in this workbook somewhere too. So watch things fan out. Now, Jeff, I like using nmon. Have you looked at that yet?
Yes.
The main reason I like nmon is because I can group disks together. So when I have a large disk farm, I can say put these disks as home, put these disks as scratch, and I can get a better consolidated report. I also use top disk quite a bit, but top disk has been broken for the past couple of years. I do have a newer top disk in February or March. The April release, top disk got fixed. And also SAR-DP for pretty. And again, what I'm looking for are dominating disks. If I've got 400 disks out there, I don't want 4 disks taking all the heat. You may have to worry about raw partitions for database needs, but I don't see raw partitions being used as much anymore. Instead, they're using these raw partition files that are Oracle-based files. And again, choose the right disk for what you're trying to do. You know, for years, people always ask, what kind of computer should I buy? And I first always ask, what are you going to do with it? So once I understand what they're going to do with it, that helps me fit them to the right type of system for what they're going to do. And again, I prefer to get things direct attached. NFS is probably your worst choice. NFS is for convenience. I don't see Samba around much anymore, AppleTalk, but they're still out there. And then CXFS or Lustre. So there's just kind of different directories to pull off and split off. Also, why a scratch directory? POSIX by default has jobs running in home by default. That creates contention on the file system where the interactive user is. Now, the compilers use $tempter by default for their scratch I.O., and bar temp is the default. But that could be creating contention on root, for example. The other problem in a batch environment is I want a unique directory. If I submit the same job twice, they might open up files that have the same naming convention, and then you get a file name collision. And also a removal of scratch files when I'm done. So 30 years ago, when I did a Cray2 class like this, we had the Cray2 completely unusable in 20 minutes because all files were permanent instead of scratch, and we basically filled up their file systems. Also, I do like it. For example, NCSA does have separate file systems, one for bandwidth, one for latency, maybe a third one for archiving. Within SGI, we used to have ptemp, which was a temporarily permanent file system. Temp was generally not scrubbed unless full, but ptemp would get scrubbed after 7 days and give you a 7-day retention period. And it's generally nice to have, like, message of the day explaining the file system politics of what you got. So you might have one file system designed for large sequential and another file system designed for small random, depending upon what applications they're running there. So just try to get this out of the way. I'm going to go for probably 15, 20 minutes. I basically go 4 hours every day, and we're getting there. So proc partitions is there. It was a main file in 2.4 kernels, but in 2.6 it's just major, minor number, number of blocks, and the name. You need to be able to track major, minor numbers. Sometimes it's just a major, minor number in varlog messages, for example. Also, let me go off to my desktop here. PS-E, grep for flush. The flush daemon, it's one flush daemon per file system now, and there's a major minor number there. So you need to be able to map that back. Now let me get back to that when we get into XVM. And by the way, Jeff, I'm still seeing SAR-DP have problems with major numbers that are 3 characters. There is a fix for that, but it still seems to be showing up a lot. I'll demonstrate that tomorrow. So here's the main file, proc disk stats. This is where IOStat, where top disk, where SAR, NMON, where everybody's getting PCP, where everybody's getting their disk statistics. So we've got a major number, a minor number, and then the name of the device. Again, name of the device is not persistent across reboots, but this file is rebuilt upon reboots. Then we've got read statistics, so we get the number of read I/O operations. An IOP. An I/O operation is a single packet command specifying position the head to this location and do this number of blocks. Block trace can trace each individual IOP. Now, we're going to have to talk about this tomorrow again, but there's something called the elevator. In fact, when I go to my I/O stages here, the elevator is also referred to as the block SCSI layer. The elevator is basically a list of I/O operations that are sorted and merged. So if we sort them and two of the IOPs become contiguous, we're going to merge them together. And by the way, by default, there's 128 I/O operations in the elevator. Think of the elevator as going up and down a list, and then sorting it and merging it. I'm going to have to talk about dev-attr where we can configure some of this stuff, because some of our devices now, we are turning off the elevator and doing a no-op and letting the RAID controller do all the work. So let me come back to this. So a read merge says I've got two IOPs. After the sort, they are contiguous, so to reduce the number of IOPs going to the device driver, we're going to merge them. And there's some bad things going on in this area. We don't want to take a large request, break it down, merge them back up, break them down, merge them back up, and break them down and merge them up again. And that is happening right now, quite a bit. Hetty has some patches for the kernel to do that, and there's also some XVM patches. Let me come back to that, but if you take a look at like Appendix E, Appendix F, there's an example from a site where we can see the breakups and the merges. So let me come back to that. Also then we get the number of blocks read, and then percentage that the device was busy doing reads. I wish that the statistical tools would separate busies between reads and writes. How busy is it doing reads and how many is it writes? So after reads, we get write I/O operations, writes merged, number of blocks written, milliseconds the device is busy doing writes. Then we have number of I/O operations that are in progress, and then milliseconds the device is busy, and I don't ever use it, I don't know anything about it, but waited milliseconds. Now PCP can get to these so we can track reads and writes in total, blocks or by bytes, and track the merges, and we can track how busy the drive is. And then the average number of I/O operations that are queued up. And PCP, by default, the one I had is merging all I/O operations together. And by the way, Jeff, GPFS, none of it showed up. So there was no block, even though there was a /dev block device for GPFS, there were no statistics. It wasn't using the elevator. So you couldn't see any of the I/O going to GPFS. I would like to look at Luster a little bit more, but I'm assuming Luster is the same scenario.
Luster has its own PMGA, though.
Yes, but I'm just saying, does it show up? Does it go through the block SCSI layer such that it is seen by SAR and that sort of thing?
I don't know. You could ask Nate.
Yeah, I need to come back to that. We can also break it down on a per partition basis. So the tools, when I've got I/O going on and I see I/O wait showing up in top, for example, I can use NMON. I'll show you that. One nice thing about NMON, it does have high watermarks, but the main reason I like it is there's a -G option, so I can group disks together and consolidate them. The other command, top disk, has been broken for a while, but that will tell me the top drives that are busy. *-DP, there is a problem where major numbers that get too big, you're going to get the major minor number instead of the device name. And I'm going to be using all this in demo first thing tomorrow morning. *-W just to see if I get any swap IO. Now, Nmon and IOTop I pulled down from the web. They are not integrated in Red Hat or SLES yet. Nmon comes from IBM. And IOTop, I still like it. It's still a little flaky for me, but it's still useful for me. IOTop is going into /proc/ whatever the PID is, /IO. So with Nmon, I can see what drives are busy. With the file system layout spreadsheet that I want you to do, you'd figure out what file system that is. And then you could use IOTop to see what processes were doing IO into it. A couple of weeks ago, it was easy to see syslog and varlog messages being stormed from the out-of-memory killer. When I tried it today, IOTop wasn't built right. I didn't have all the Python stuff there. So IOTop will tell you by bytes sort, by the bytes transferred, which processes, which PIDs and names are doing IO. FUser will tell me what's open in a file system, but not whether there's IO going on. strace, then I can attach to the process and see what its IO characteristics look like, if it's doing direct IO or cached IO. And another trick that I use, LSOF, list your open files. If the file is still open and you're filling up a file system, if you sort by column 7 of LSOF, that's the size of the file, and you might be able to find the file that's filling up the file system. Now, removing the file will not free up the space. You can remove the inode, but the space is still being allocated, and you have to wait for the flush. You have to wait for the sync to finish before the entire file will get removed and the space freed up. That's something that I'll try to do tomorrow. There's also dkviz. I don't use dkviz too often. I'll explain that coming up. So here's just a sample of FUser. Here's a sample of IOTop. Now, here's the thing here. The numbers that it's deriving here are getting bogus. I don't believe that number. When I'm using IOTop, I got to say this is garbage or this is useful. It can give me very useful information as long as I know how to not trust it and not believe everything I see. We are not getting petabytes per second or terabytes per second here. But I am able to spot the processes that are doing I/O. Okay? Then here's an LSOF example, and again, I'm grepping for any regular files, sorting by column 7. In this case, we're going to see this tomorrow. My code 8 and code 7 generate a file in bar temp that's the PID. And when I run this through, I can spot the program and the file that might be filling up the file system. But again, with this technique, you have to be able to throw things away and say, after that are DSOs and this is all garbage. I don't care about those. So just like the IOTop, I've got to be able to throw away things that don't make sense. Here's an strace example using CP as an example. This actually happens to be Itanium because it's doing page I/O 16K byte. On UV, it should be 4K byte by default. We're going to look at that tomorrow in great detail. Here's dkviz. Now, the thing I don't like about dkviz is it shows high is good metrics. But the valleys where nothing is happening, I don't know if the valley is idle or simply not doing IOPS because there's a problem with the device. So benchmarkers and other people like to go in and look at the good metrics, number of IOPS and bandwidth. I like to go in and look at the bad metrics. How busy is the drive? What's its service time? What's its wait time? And dkviz won't do that for me. So I can't tell if these things that are low in the chart I can't tell if there's simply no I.O. going to them or they've got some sort of problem. I'm going in and looking for the bad stuff, not the good stuff. Here's a PM chart doing IOPS per second. Here it is per disk. Now here's IOStat. I'm assuming, Thomas, you've used IOStat before?
Yes.
Be very careful. People get burned by this. The very first record is since boot, not during the sampling interval. So when I did an IOStat-M for having it in megabytes and a -X to give me the disk statistics, this very first sample I see here was since the system booted, not during that first second of looking at it. Then it stabilizes into 1-second samples in this case. So that has been useful for me because then I can, if the event is already over, I can still profile and see what's the average for the, since the system booted for a particular device. But don't misread it. The first record, the first sample is since boot. Also, I'm still waiting for it in SLES, but the newer IOStat has a -Z option, I believe it is, that says don't print idle drives. So I can get rid of all the stuff that doesn't show anything. If I got 400 drives, I only want to see things above a certain threshold. I don't know if you got a hard copy, but I usually put notes underneath where I will pipe it into awk and then say only print things that are above a certain threshold. So these are the fields. Read, request, merge. So I sort my requests in the elevator, and if they're contiguous, I merge them together. Write, request, merge. Notice that there were 200, 300 IOPS that were merged together. Then my read IOPS per second, number of read I.O. operations per second, number of write I.O. operations per second, so I can see I'm writing here since boot, and then my bandwidth, megabytes per second for reads and writes. Then I got my average request size. This, unfortunately, is in blocks. But I do want to know, am I doing lots of little I.O.? So here's one on SDB where it was little I.O.s, and here's one that's doing large sequential I.O.s. So I got to multiply that times 512 to make it user-friendly. Now, this is averaged for the file system, or I should say for the device. Block trace would give me each individual IOP size. Then I've got my key 4 metrics here. These are the ones that matter to me. My average queue size, how many I.O. operations are queued up. So I'm seeing a lot of I.O. operations here. Then I got my average wait and average service in milliseconds. Look at this, I've got a 6-second wait on an I.O. operation. Now, I'm not going to treat that as exactly 6 seconds. I'm not going to sit. I tell myself I'm not Arthur Anderson. I don't care if the books don't balance. PCP engineers didn't like to print this sort of information because of the way it's counted, and they would go into a description about temporal versus stochastic and how it's counted. I'm not going to take that too literal, but I am going to say if this thing is high, I want to identify what's going on and try to back it off. My rule of thumb, I want these two added together to be less than 50. Sometimes I'll say 60 or 80, but I want them less than 50 milliseconds, particularly on a root file system or a home file system. So this is the average amount of time that I waited for my I.O. And again, I'm queued up, so if I have a long queue size, I'm going to have a long queue wait. I've seen this get into hundreds of thousands. I've seen it get into minutes for an I.O. operation occurring. I was actually hoping to see that with bar log messages from the event yesterday, but my SAR file was bad after the system was rebooted with more blades to the partition. So again, I want those two to be less than 50 or 60. This one then says how busy the drive is. Now, if I am a home or a root, I'd like that less than 30. But if the purpose of this file system is to read or write, and it should be busy all the time. If I'm reading a satellite video stream down, I would expect the file system to be busy as I spool the data out to the drives. So your rules of thumb are different depending upon the type of file system. So here's an example of NMON, and again, I'm not seeing it here, but there are possibilities of high watermarks that are in there. And again, the main thing I like is I can use a -G option and have a configuration file that says merge everything together. And there is you can hit a period and then it would only show drives that are busy. What I don't like are drives showing up more than once, and these are XVM. So I'm seeing the XVM volume partition and then the drive itself. And that makes it very noisy. Both top disk and NMON basically show the drive multiple times. And here I am trying to reduce the amount of data that I'm looking at, not double it. So here's a SAR-DP. Now the P is printing out a device name. Without the P, you get a major minor number. So this is everything that we had before. And by the way, this is written by the same guy that did IOStat, but he's not putting in merge information here. The thing I don't like about IOStat is I don't have it historical. So I can look at things with IOStat Live because it's a common tool. And legacy-wise, IOStat's always been very verbose for the IO statistics. The original SAR command 5-10 years ago didn't do much for disk. But nowadays, SAR is actually saving all the disk data out there. And if I had a full IOStat capability with SAR-DP, I've got history on merges and things like that. So I'm missing the merges here. But here I've got number of I/O operations per second, read sectors, and again, those are in kbytes, not as friendly. Average request size, average queue size, and again, my service and waits. And here again, those are above 50. And then how busy the drive is. Here's top disk. Now, it is broken in the past year, 2 years maybe, but it has been fixed as of April. And it's sorting by how busy the drive is. And here I am getting an average record length. I'd like to see that, like stripe width size and stuff. We'll do that tomorrow. So here's my basic summary. With SAR, if my CPU or if my disk busy is high, greater than 30%, but my service and waits are less than 60, then I primarily look for head movement. Head thrashing is going to keep the drive busy without affecting the service and the waits. So, things that cause head movement, fragmented files. XFSDB has a frag-f command, and I can do an XFSB map with 3 V's on it to look at a particular file to see how it's placed. When I was looking at the U.S. Postal Service database market, they did have several scratch files that were fragmented and not contiguous. Also, fragmented directory information. So there's a frag-d command and df-i to tell me how much metadata I have. Again, varspool news is a very common one that can have a lot of metadata. Every article posted has a inode to it. The other thing that can cause head movement is too many partitions. So with parted or XVM, I want to make sure that I haven't partitioned the drive too much. And another thing that can cause it is log activity. The log or the journal is in the middle of the drive, at least for XFS. I don't know where it is for Extended 3. So I'm going to get into this tomorrow, but looking at XFS statistics. And we were seeing a little bit the other day, XFS_log wait type of events. So if I have a busy log, I might make the log external and get it off the drive. 10 years ago, the journal was only in the middle of the first drive. And in the Stripe group, you'd see the first drive be like 90% busy, and all the other drives were like 60% busy. Once we got that journal off that first drive and put it on a separate disk, then all drives behave better and more coherently. Basically, again, when you stripe, the drives will behave like they're the same drive. And another issue is multiple processes in the same file system. So you can use FUser to find out what's in a given file system. The other thing we're going to talk about tomorrow are XVM statistics. Those are broken right now. I'll show you what I mean tomorrow. Now, the other end of the spectrum, if my drive is not busy, but my service plus weight is high, then I look for what I call overstriping. Lots of little IOs into a wide stripe file system. So with top disk, strace, and XVM statistics, I can see how well I'm spreading my IO across the individual drives. Another thing that happens, when my file system starts filling up, we start throttling my allocation. We try harder and harder. The intent here is to avoid fragmentation in the first place so I don't have to take the penalty later. So you're actually going to see the wait time start creeping up as your drive gets busy, or full, I mean. By the way, in one class, I was sitting there watching it, and the drive went 100% busy, and we went through all of this and couldn't find why it was busy until we looked at bar log messages. The drive was dying underneath us. So a failing drive will also show up as busy as you get retries and stuff. We just happened to we were trying to find the IO that was making root busy. Happened to pop up top, saw syslog pop up, went to syslog, and immediately saw the drive failing. Did a reboot, and the drive never came back. So a failing drive can also create a busy. Any questions on this? So this is that big drawing that I want to come back to tomorrow. So I've got it in more detail here. So I've got my application user space. If I'm using Fortran, there's going to be a library buffer in between. And then I make a IO library or IO system call. That's going to call a section of the kernel called VFS, or Virtual File System. At the VFS layer, we don't care whether it's XFS or extended 3. It's just generic. And then we figure out what file system it is, and then jump to the file system handlers for that particular file system. So XFS knows how to understand XFS inodes, and extended 3 knows how to understand its inodes. Also, my IO then is going to move from my data array into the page cache, which I've been calling the file system buffer cache. Basically, all of memory is cache, so they call it page cache. Whereas older Unixes and IRIX, for example, the cache was a subset of memory. From there, we go into the volume manager. Everything over on the left here is logical I/O, and then the volume manager is going to turn that into physical I/O. So this is my logical, and this is my physical. I have seen cases even recently where the physicals were higher than the logicals. You don't want that. The whole purpose of a cache is to hold the data so I don't have to do the physicals. Now, coming out of the volume manager, we then go into the SCSI block layer, which is where the elevator is. And this elevator, by default, is going to sort and merge. From there to the device driver, and then from there off to the fabric or whatever. So this elevator, the default has been CFQ. I'm going to come back and demonstrate this tomorrow. But in sys block, device, queue, and our request is the number of I/O operations that are in the elevator. It's 128 by default. Now, the older 2.4 kernels just did an up and down the elevator to sort and merge. In 2.6, they created 4 elevator algorithms. The default is still complete fair queuing. Each process has a request queue that's sorted. This means that one process cannot dominate the I/O queue, cannot dominate the elevator, can't plug it, so to speak, with lots of IOPS and maroon in another process. So we're going to round robin between processes. Another one here called deadline. The queue is sorted by location, but we have a separate sort between the reads and the writes. And there is a third queue here that if it has expired, it's put into a 5.0 queue. Now, I have not been able to find in the kernel where these numbers 500 milliseconds and 5 seconds come from. This comes out of Robert Love's Linux kernel development. But I haven't seen, there's no way of tuning it, and I haven't seen it where it's actually happening in the code. But basically saying, if my request has been waiting for 500 milliseconds for a read, or 5 seconds for a write, then it's put on the FIVO queue and addressed immediately. Again, we're trying to prevent starving and marooning. There's also an anticipatory scheduler. It's still the deadline scheduler, but it stalls. And again, the documentation from Robert Love, Linux kernel development, says 6 milliseconds, but I can't confirm that. But this, if I stall, and again, we do have delayed allocation going on here too, this gives the application more time to generate requests. The more requests generated, the more chance of merges. The algorithm that we are using nowadays, though, SGI, we're turning it off and going to a no-op. We're letting the RAID controller do that. So this is how the device driver and the SCSI block layer are tuned. This is an SGI-specific package, and it's going to run a script when we boot the system in rules.d. There's a dev.attr.rules script. By the way, it's in the SG Tools RPM. It runs this Perl script on boot and basically reads out of this file the settings and then writes them into the sys file system. Now I'm going to come back to this as a demo tomorrow morning. So this dev.attr.conf file is how I can adjust things at the driver level. Now right now it can only work on devices. It will not work on XVM. And I've got an RFE to allow it to work on XVM. So in this example, I've got vendor equals any vendor that is IBM, any model that is a DNEF, and any LUN coming from it is going to have max sector K bytes. This is increasing the DMA size, the maximum DMA that the driver can handle. I'm also adjusting the queue depth. Now there are 4 things I can do here. Queue depth, max sector K byte is the maximum DMA size. So if I want to do large sequential to a RAID that's configured for 4 meg, I need to up that to get to 4 meg. Also read ahead. Now by default, read ahead is twice the stripe width. But maybe you're doing random I/O and don't need the read ahead. You can also specify a different scheduler here. Okay. So let me go to my desktop here. So I'm going to go into /ITSI dev-attr, and if I cat this conf file, right, first of all, let me do an LSCSI too. So my drives are Seagate drives, and there's the model number. Now, if I was a Maxtor drive in this particular model, they are setting the DMA max sector K byte to 256K. And somebody has gone in and determined that that's probably the best value for that particular drive. I have a Seagate drive, therefore my large requests, the largest I can go is 1 megabyte. Also, we're covering SGI, so DD devices, these types of devices are 1 meg. The TPs and the ISs can go up to 2 meg, and the DDNs can go up to 4 meg, max sector K byte. That's the largest DMI size that they can do. Also, they had an example here where the DDNs were setting a queue depth of 8. I'll come back to that tomorrow. And notice down here, iSCSI, for example, they got scheduler equals no op. Here too, the DDNs and the ISs, they're setting the scheduler to a no op now and letting the RAID controller do the sorting and managing the IOPS. So if I go into /sys block, and I'm going to pick SDA since that's my root disk right now. Then I'm going to go into Q. So these are where these things are adjustable. Let me do a cat of max. So right now, the max hardware sector kbyte is the largest that I can raise max sector kbyte. So by default up here, we did have it at 1 meg. Well, it's kind of scrolled off. So that 1 meg got there during boot from this rule. There's where it is. But I could adjust that and change that to 4096 and raise it up to max hardware sector kbyte. That's the maximum. I'm going to cat NRs. So again, only 128 I/O operations on the elevator. I'm going to play with that tomorrow. Let me cat the read ahead. The read ahead is only 512 kbyte. That's the default for this. And again, we're not striping here. And I'm going to cat the scheduler. And the brackets around it indicate the default scheduler here is a CFQ. So these are all tunables. Robert Love's Linux kernel development does get into these. But if I want to do if I want bandwidth, I do large sequential I/O. I don't want to be breaking them down. I'd like to set up a file system that can take a 4 megabyte request and spread it across the LUNs in the RAID. And in this case, I'm only pushing a 1 megabyte request, not a 4 megabyte, but I can raise it up to 4 meg. Now again, there's nothing here for XVM yet. So that device file, dev-attr file, is not valid for XVM. Let me do that tomorrow when we go to XVM. Any questions? So let me go back to the workbook. The next piece has been broken for a while. It works in /10 SP2. It works on OpenSUSE. Thanks, Jeff Hanson's the one that found it working on his OpenSUSE version. And it is definitely going to be working in /11 SP2. So I have confirmed that, and it is working in kernel of the day right now. But it's not working on /11 SP1. Block trace allows me to profile each individual trace. By the way, it does work on RHEL 6. And RHEL 6 even comes with SeqWatcher installed with the distribution by default. So SeqWatcher is basically plotting the head movement. So block trace, I don't want to get into detail, but all the different events that you can track and all the different fields, it's pulling apart the IOPS. And then I did a B trace on a particular device here, and we can see flushing going on. We can see a particular queue that's doing some stuff. Then I did block trace and dumped it into block parse to look at it in a different way. The one I want, this is just parsing and showing you what the fields mean. But the one I want, I don't care about this one either. Here's the one I want. Running block trace into block IO mon. And then you're getting a histogram of your packet sizes. So the other case, you're getting each individual IOP, which gets too verbose. This will tell you generally what packet sizes, what IO operation request sizes you're doing. So I'm done for the day. Split out your file systems, know your application characteristics. I'm going to demo this stuff in the morning, and I'm also going to start building some XVM. I think I'm just deciding on the Floyd 3. I think I'm going to put together an XVM on Floyd 3 this afternoon, and then let you take a look at it and use it tomorrow. And then if either of you wanted to try it and redo it, that is fine. Both of you do have background in this area, so I really just want to put one out there for you and have you figure out what I did. So on labs, there is an FS layout lab, and once I've got a RAID built, an XVM built from the RAID, you can take a look at the RAID lab. The RAID lab actually is ready right now. I just haven't put them together as an XVM yet. So feel free to look at the FS layout lab and the RAID lab, and any other things that you want to play on. Thomas, if you want to practice anything else, let me know, and I'll come in there and help you with any sort of other topics you want to deal with.
Okay, great. I just actually want to ask, are we supposed to log into Kramer to check out the file system on there? So Kramer seems to be down. I don't know if it's just unreachable from my office or if it's down.
Let me check that. And I haven't logged into it for a while myself, so there is a, oops. There is an L3-Kramer that I'm going to try to go to here. And I think that's a Telnet. I don't think they have SSH running there. Oh. Let me look at that during lunch.
Okay. No rush. I just thought I'd point it out.
Yeah, no, I needed it. So with that, I'm just going to call it a day. There's still some of the memory labs for you to play with as well, but I need to get Kramer booted. Okay?
Great. Thanks, Dave.
Thanks, Dave.
So I'll send you an email when I've got something more to look at. In the meantime, you can also bring up SMEE GUI on Floyd 3 and see how the TP9400 is put together. But I'm going to put that together as an XVM this afternoon as well. So I'm going to be pussing here for a little bit before I take my lunch break. But we'll see you when you're ready. Okay?
Yep.
Sounds good. Bye.
Thanks.
Bye.
Bye.